Diksha Didi. Good afternoon. Uh, so should we start from where we left yesterday? Okay.
Hello.
Hello.
Yeah, sorry, I'm back.
Yeah. So should we continue from where we left yesterday?
Yeah.
All right. I'll just share my screen. Okay, so C++ identifiers. So all C++ variables must be identified with unique names. So basically in this chapter we're gonna see how to give the names of your variables. So these unique names are called identifiers. Identifiers can be short names like X and Y and more descriptive names like age, sum and total volume. Note, it is recommended to use descriptive names in order to create understandable and maintainable code. So for example, here there are two integer variables. One is int minutes per hour and one is int m. It int m is okay, but not so easy to understand what m actually is. So it's always suggested to give descriptive names. So there are some rules of defining identifiers. So the general rules for naming variables are: names can contain letters, digits, and underscore. Names must begin with a letter or an underscore. Alright, so names are case sensitive. My var and my var are different variables. So let me show you. So if I create a variable int, or I'll just show you in the Replit IDE. Alright, I'll just open the previous REPL that we made yesterday. Alright, and it's just opening. It will open in a second. Right. So over here, if I create two variables, int my var and with v uppercase and like 50, and then I say sorry, and then I say int my var but v with lowercase is equals to 40, then these two are different variables. When accessing my var with v uppercase, you'll get the value 50, and when accessing my var with the v lowercase, you'll get 40. So when I do cout and my var, then I'll get, alright, so it's just running. So I'm getting 50, but when I say when I give lowercase v, then we'll get 40. Alright, is this clear?
Okay. Yeah.
Okay, so names cannot contain white spaces or special characters like exclamation, hashtag, percent sign, etc. So reserved words like C++ keywords such as int cannot be used as names. So there are some reserved words like int is used for defining the data type. Similarly, you have many reserved words like bool, double, float, string that are used to define data type. So you cannot keep the reserved words as the name of your variables.
Okay.
So next, we are on constants. So when you do not want others or yourself to change existing variable values, use the constant keyword. So if I want to make an unchangeable variable, for example, const pi is equals to 3.14. Sorry, right? So I don't want anyone to change the value of pi. So I have said that this value of pi should be saved in a constant, and it's a double value. So I'll not give int, I'll say double. So now when I try to say pi is equals to 3.234, then it will give us an error. So constant will not allow the variable pi to be changed. Alright?
Okay.
So like they have given an example, constant int my num is equals to 15, my num is equals to 10, right? So it will give us an error when trying to change a constant variable's value. So over here also we have they are giving two examples, constant int minutes per hour and constant float pi. So you can create any variable a constant, right, of any data type. You can create any variable a constant. Do you have any doubts?
No, okay.
Right. So till now we were just giving the output to the user. Now what if we want to take in input from the user? So in this chapter we'll learn how to take in the input from the user, and we'll also learn to build a very simple calculator. So,
Okay.
first C++ user input. We have already learned that cout is used to output or print values. Now we will use cin to get user input. Cin is a predefined variable, or you can say a method that reads data from the keyboard with the extraction operator. So till now we were using the insertion operator with cout. Now we will use the extraction operator with cin. So CN is also part of the standard namespace in the IOStream library. So you don't have to make any further import include statements to use CN.
Okay.
Alright. So like cout, it is giving CN. We have to give CN like this. And in the following example, the user can input a number which is stored in the variable x. Then we print the value of x. So over here in this example, what we have an integer x, right? We are printing the value type a number. Then we are taking in the input. So wherever this string ended, from there the input will start being taken, and whatever the value the user enters will go in x, and then it will print your number is and whatever the value of x is, right? So I'll just show how to do it over here. So for example, we have an input, in integer variable x, right? Next what we'll do, we'll tell the user to enter a number. So we'll say cout, and we'll say enter a number, and we'll just give a space so that it's more clear for the user. Next we'll take say cn, and whatever the value the input gets, we'll save that in x. And finally we'll just show using cout the value you entered was, and we'll give a space, and then we'll use the insertion operator once again to show the value of x. So over here it will show enter a number, then it will take in the input, and whatever input it gets, it will save it in x. Then it will print the value you entered and whatever the value of x was. So when I run this program, it's saying enter a number. So it's giving us an option of entering the number. So like 50. So the value you entered was 50. Alright.
Okay.
So good to know. Cout is pronounced as cout, used for output, and uses the insertion operator. So cout you will always use the insertion operator, and with cin you will always use the extraction operator. Now
Okay.
we'll create a simple calculator that will add two values. So over here we'll define two variables x and y. So int x comma y. Then we'll create a variable sum. Right. So we'll not look at that code. We'll just try to code it ourselves. So what we'll do, we'll first say to the user, enter the first number, right? And then we'll take in the input to get the first number, and we will save that first number in x. Next we'll say cout, enter the second number, and then sorry, I added the extraction operator. We'll use the insertion operator with cout, and then we'll take in the input and we will save that input in y. And when we have both the inputs, we'll take out the sum. So sum is equals to x plus y. So now we have the sum of the two numbers. Now we just have to show that sum. So we will say cout the sum of the two numbers was, and then we can use the insertion operator once again, and we'll say sum. So over here, this is a simple calculator to take out the sum of uh, two values given by the user.
Okay.
So enter the first number it is saying. So we'll select 20. Enter the second number, 30. The sum of the two numbers is 50. Okay, given was, so is 50. So do you have any doubts with this program over here?
No, got it.
Okay. So this is a basic calculator. Once we learn operators also, then we will create a more advanced calculator with all the operations. So
Okay.
now we have data types. So as explained in the variables chapter, a variable in C++ must be a specified data type, right? So every variable should have a data type. So we have int, we have float, we have double, we have char, we have bool, we have string. We have already seen these data types. Now these basic data types are explained over here, how much memory each data type will take. So the data type specifies the size and type of information the variable will store. So boolean will take 1 byte of your memory. So in your memory, every variable has a location, right? And it's all the values of the variable needs to be saved in some memory, right? So how much memory will each data type variable be saved in, that is being told in this table. So it's saying that boolean whichever boolean variable you have, it will take 1 byte of your memory, right? And it will store true or false values only, right? Next we have the character data type. It will also take 1 byte of your memory and will store a single character, letter, number, or ASCII values, right? So you can save a single number also in char, in single quotes. Next we have int. It will take 2 or 4 bytes of your memory, stores whole numbers without decimals. So this will only store whole numbers without decimals, and how big the number you store, according to that it will take in the size of it will occupy the space of your memory, right? So if I have a very big number, so it
Okay.
may occupy 4 bytes, but if I have a small number like 20, it may occupy 2 bytes, right? So according to the number you give to the
Okay.
variable, the memory will be allocated to the variable. Next we have float, which will always occupy 4 bytes. So it will store a fractional number containing one or more decimals, sufficient for storing 6 to 7 decimal digits. So you can only have 6 to 7 decimal digits when using float. And the main difference between float and double is that in double you can have 15 decimal digits, and float you have 6 to 7 decimal digits. So to always remain safe, we use double in C++. Both are used
Okay.
for storing decimal numbers, but one double can save 15 decimal digits and float can save 6 to 7 decimal digits. So we will see these data types in detail in this chapter. So first we have the numeric types. So we use int when you need to store a whole number without decimals like 35 or 1000, and float or double when you need a floating point number with decimals like 9.99 or 3.14515, right? So it's basically explaining all the numeric types. All the numeric types are int, float and double, right, in which you can save a double numeric value. So float versus double they are giving over here. So we have already seen these data types, so we'll just come to float versus double. So the precision of a floating point value indicates how many digits the value can have after the decimal point. The precision of float is only 6 or 7 decimal digits, while double variables have a precision of about 15 digits. Therefore, it is safer to use double for most calculations. And now we have scientific numbers also. So a floating point number can also be a scientific number with an e to indicate the power of 10. So in float also you can save a scientific number, and in double also you can save a scientific number, and it always contains e, right? So over here you have 12e4 and then you have 35e3. So e basically represents 10 raised to the power of 10, and you can have
Okay.
it capital E or small e, it's up to you.
Okay.
And now we are on booleans. So we have already seen booleans. A boolean data type is declared with the bool keyword and can only take the values true or false. When the value is returned, true equals to 1 and false equals to 0. So now this is important. Okay, I'll just close this. So when you have a boolean, bool, and for example, my bool is equals to true, and when you try to show the boolean value, so when I say see out my bool, then you'll expect to get true, but you will get 1. So before enter the first number you can see 1 over here. So whenever you try to show whenever you try to access your boolean value, true will always give you 1 and false will always give you 0.
Okay.
So over here we try to print it. So true gave us 1. If we gave false over here, it would have shown 0. I'll just stop the program and then so we are getting 0 over here, right here.
Oh.
Okay. So they are just giving us an example of using boolean data type that we have already seen. So boolean values are mostly used for conditional testing, which we will learn more about in a later chapter. Next,
Okay.
we are on character data type. So the char data type is used to store a single character. The character must be surrounded with single quotes like single quotes A or single quotes C. So you can store one character of any type like a number, a letter, a, um, an operational character, a arithmetic operator. You can store one character in your character data type. So in single quotes, right?
Yeah.
So I'll just show it in the REPL only. So here we can say char and we can say my char, and in single quotes we can just say like 0, and then when we try to show my char, then we'll get 0. Right, so we are getting 0. I'll just insert a new line using the end L for more, so that it will be more clear for us. So we are getting 0, and we could have got we could have had any character like plus, so this will show plus, right? So any one character you can have in the character data type. Next, you have alternately you can use ASCII values to display certain characters. So ASCII values are basically some values.
Are
Uh,
they the same of Python?
what?
They're the same values मतलब A to Z that are given in Python.
I can't get your doubt. Sorry.
We have those ASCII values in
Yeah,
Python also, right?
yeah,
So
ASCII
I think we've
values.
done them.
Yeah. So there's this whole ASCII table reference whose URL I'll give you. So you don't need to remember all the values in the ASCII table. It's all used for further complex calculations and all, which we will not be seeing right now. But over here, these are all the ASCII numbers which are associated with the character. So like 33 is for exclamation mark, and like 86 is for capital V, right? So these are all the ASCII values that you don't need to remember, and you will not much often use these.
Okay.
Alright. So next we have string data type. So the string types. So the string type is used to store a sequence of characters. So it is very similar to char, but you can store a sequence of characters using the string type. Alright. So this is not a built-in type, but it behaves like one in its most basic usage. So for the most basic usage, the string you can use the string type, but this is not a built-in type. You will actually have to import it from somewhere else in your C++ program um, when you have to do complex work with the strings. Right now basic work you are doing with the strings, so it will perfectly work. But when you are using methods on strings, then you'll have to include the string data type from somewhere else. So right now we'll just say string uh, right my string, and we can give a sequence of characters, but it should be enclosed in double quotes like hello. And now we can just show my string. Alright, so we are getting hello over here. So over here, to use methods on strings, you must include an additional header file in the source code, the string library. So like we are including IOStream, we also have to include the string library. So let's see the example. So over here, I'll just include, sorry, hashtag include the string library. So now what will happen, everything will remain same, but when we have to use some methods, like if I want to trim the string, I want to extend the string, I want to add something to the string, then those methods I will be able to use on the string. So complex operations can be done on the string when including the string library. Alright, is this clear?
Yeah.
So you learn more about the strings in our C++ strings chapter. So now
Okay.
we are on operators. So after operators we have directly strings. So that's we'll try to cover that today only. But let's see. So C++ operators are used to perform operations on variables and values. So in the example below, we use the plus operator to add together two values. So using the plus operator, we are adding two values. So these operators are very similar to the ones in Python, right? So using the plus operator, we are
Hmm.
adding two values. So although the plus operator is often used to add together two values, like in example above, it can also be used to add together a variable and a value, or a variable and another variable, right? So we added a variable and another variable in the calculator over here. Like when we did sum is equals to x plus y, we are adding two variables, right? So C++ divides the operators in the following groups. So they are arithmetic operators, they are assignment operators, they are comparison operators, they are logical operators, and they are bitwise operators also. Bitwise operators we are not gonna see in this tutorial, right? We are only gonna see arithmetic operators, assignment operators, comparison operators, and logical operators. All right.
Okay.
All right. So arithmetic operators. Arithmetic operators are used to perform common mathematical operations. Like you generally have all these arithmetic operators like plus, minus, multiplication, division, modulus, increment, and decrement. So we know the plus is used to add together two values. So minus is used to subtract two values. Now this star is used to multiply two values. So when using the star, you will be able to multiply two values. And this slash, not the backslash, the forward slash will divide two values. Modulus will return the remainder of your division. So, for example, I divide, instead of taking out the sum, I use the modulus operator. So, what will happen over here? It will give us the remainder. So, for example, I say first number is 5, second number is 3. So the remainder of the two numbers when divided is 2. Next you have plus plus, so this is used to increment values. So example, I say x plus plus, so this will increment the value of what x, and if I say x minus minus, then it will decrement the value of x.
Okay.
So you I think we have plus plus and minus minus in Python also.
If whether plus equals to 1.
Yeah, and plus equals to is in the assignment operators. But I think we have
Okay.
plus plus and minus minus in Python also, so let's not worry about it. So
Hmm.
assignment operators are used to assign values to variables. So in the example below we use the assignment operator equals to assign the value 10 to variable called x. So we are already using the assignment operator everywhere in variables and many places. So the addition assignment operator, that is the plus equals to operator, adds a value to a variable. So this, so I'll just open the replet. So when I say sum plus equals to 2, then what will happen? Whatever the previous value of sum is, we will add 2 to that value. So we have many operators like this, like minus equals to, that will what minus equals to will do, that whatever the value of sum is, subtract that subtract 2 from that, and then give the value, set the value of sum to that. So for example, the value of sum is 5, and you say sum minus equals to 2, so it will subtract the value of 2 from 5, right? And then it will set the value of sum to 3, right? Because 5 minus 2 is 3. Similarly, for
Okay.
all the arithmetic operators like multiplication, division, modulus, you have the it's assignment operator also, like multiplication equals to, division equals to, and modulus equals to. Then you have and equals to. So now and is a new operator for us. So for example, we have int x equals to 5 and we are saying x and equals to 3. So you are getting over here 1. But if I say int x and equals to 0, so you get 0. So this and is basically your one of your, I think it's your comparison operators. It's one of your comparison operators. So when doing and 5 and 3, when we were doing 5 and 3, then you had both the values of this give us true. So every positive the positive numbers give us true. So if we check if 5, so that will give us true, right? So when doing 5 and 3, we're getting two true values. So we'll, the overall output will get true, and true's value is 1. So we, when we print the value of true, we get 1. I don't think it's clear.
No, I got that. It's basically true and false. Huh? Like
Yeah,
both positives are true.
yeah, but 0 is not true. We know that 0 is false. So when we did 5 and 0, then one of the values was false. So that's why we get the overall value to be false.
Okay.
So when we say 5 and 0, so we get 0. That that means false. And we similarly have an or equals to operator. Or equals to checks that if we have one value true, like if we have like 5 and 5 or equals to 0. So when we do x or equals to 0, so we have x that is 5 or 0. So 0 is false but 5 is true, so the overall value will get true. So whenever one of the values is true, when doing or equals to, we'll get true. But if both the values are false, then only we'll get false. So if we say 5 or equals to 0, then we'll get 1 that shows true. Or
Okay.
we are getting 5 over here. So I don't know what is happening, but if we have both the values to be 0, then in or equals to, I think we should get 0. Yeah, I don't know why we were getting 5 over here when one of the values was true. mm, Alright, when we do 1 or equals to 0, then we get 1. When we do 2, then we are getting 2. So I think this is returning us the value itself. So when one of the values is true, it is returning us the value itself. I'm
Okay.
not, I'm getting confused with another language. So in, I think, another language or Kotlin or so, we have when doing or equals to, then we get 1 or 0. Sorry, I got confused with another language.
That's alright.
Yeah. Now these are the bitwise operators over here, like the this bitwise operator, and then you have the double arrow bitwise operator, and then you have the another double arrow bitwise operator. So bitwise operators we'll see when we after we do math. All right. So these three bitwise operators we'll see after we do math, so that it is more clear for us.
Okay.
So we are on the comparison operator. So comparison operators are used to compare two values. This is important in programming because it helps us to find answers and make decisions. So these will mostly be used in the if statements, right? So the return value of a comparison is either 1 or 0, which means true or false. These values are known as Boolean values, and you will learn more about them in Booleans and if else chapter. Right, so in the following example, we'll use the greater than operator to find out if 5 is greater than 3. So we are checking if 5 is greater than 3. So it will give us true, and it will print 1. because 1 is for true. But if we had 3 is greater than 3, we know that 3 is equals to 3 and not greater than 3, so it will give us 0 for false.
Okay.
Right? And we have many comparison operators, like the double equal to will check if two values are equal, the not equals to check that if two values are not equal, the greater than will check if one value is greater than the other value, the less than will check that if one value is less than the other value, the greater than equals to will check that if one value is greater than or equal to the value. So when we are doing 3, if we do 3 greater than equals to 3, then we'll get true, because first it will check if 3 is greater than 3. Now that is false, but then it will check if 3 is equals to 3. So it finds 3 to be equals to 3, so then it will return us true. So it will check if 3 is greater than or 3 is equals to 3.
Okay.
Similarly, we have the less than equals to operator. And finally, we have the logical operators. So as with comparison operators, you can test for true or false with logical operators. Logical operators are used to determine the logic between variables or values. So the double and logical operator will check if two conditions if two conditions are true, then only it will return true. So it will check if x is less than 5 and x is less than 10, then only this whole thing will get us true. So like we do over here, if x is greater than 4, or we can say if x is greater than 2 and x is greater than 3. Now we know x is 3, so 3 is greater than 2, but 3 is not greater than 3. So one of the conditions when you in this is false, and only gives true when both the conditions are true. Now one of the condition is false, so overall we'll get false, and false is represented by 0. All right, but if we did x is greater than 2 and x is equals to 3, then it will check if it is greater than 2. So yes, it is greater than 2 and it is equal to 3. So now both the conditions are true over here, and will give us true when both the conditions are true. So we will get true over here, that is represented by 1. All right.
Does it ever show true or false?
When printing, it will not show true or false, it will only show 1 or 0.
Okay.
And with that we have the or operator also. So the difference is that whenever one of the conditions is true, then it will give us true. So if we did over here greater than 3, so what is happening, it will check that if x is greater than 2, yes, x is greater than 2, or x is greater than 3, no, x is not greater than 3. So now over here in this we have one condition true, and whenever there's one condition true, then overall we'll get true when using or. And whenever both the conditions are false, then only we'll get false. All right.
Okay.
And finally we have the logical not. So it will reverse the result of any value, any it will reverse any result. So for example, we say not x is greater than 2 or x is greater than 3. So now this, we just saw that it is giving us true, but now we are using not. So now this is whatever we are getting to be as true, not will reverse that result, and now true reverse is false, so we'll get false. So it will
Okay.
basically reverse the result of any uh, any value. So if we just, I said not true over here, so, if I say not true over here, then it will reverse the result of true and it will give us false, right? And these were the logical operators. So we'll continue in the next class with strings.